Hey, good morning. I'm going to try to get through this video. That pollen is getting to me and my throat is scratchy and my eyes are yucky. Just be glad we're not in class today. Okay, so there's a couple of warm-up questions. I'd like for you to take a minute, write those questions down, pause the video, do the warm-up questions. Don't spend more than like 5 minutes on these questions. Okay, so I'm going to give you the answers to these questions. You should have paused the video and done them already. All right, so this first one, the integral of 3x to the 5th dx. Remember, the 3 comes out here to the outside. As you get better with these, you're welcome to, cut corners and take shortcuts. But if you're not getting them right 100% of the time, then you need to make sure that you're kind of doing them out the long way. All right, so this becomes 3 times x to the 5 plus 1 power over 5 plus 1. So that is 3x to the 6 power over 6. My 3 and my 6 reduce. So this becomes x to the 6 power over 2. And then don't forget plus c. This one over here becomes, number 2 becomes 9 times the integral of x squared dx plus the integral of 7 dx. So this is 9 times x to the 2 plus 1 power over 2 plus 1. And then with the 7, we add the x. So this becomes 9 times x to the 3rd power over 3 plus 7x. Well, the 9 and the 3 reduce. So that becomes 3x to the 3rd power plus 7x. And then, of course, plus c. Okay, so if you didn't get some of that right, or you just have questions, don't forget I'll be online at 11 o'clock every day. I'll post the code about 15 minutes before, so about 10:45. We do have a meeting today, a faculty meeting today, so if I'm not on right at 11, just be patient. Okay, so there are some other integral rules that we need to make sure that we know. So I just wrote them down here. If you take a minute and just copy them down. The integral of cosine x dx is sine x plus c. And if you look, just like with polynomials, when the result, sine x, if you were to take the derivative of sine x, you get cosine x. If you take the derivative of cosine x, you get negative sine x. So it would stand to reason that negative cosine x would be, if your integral were a positive sine x, then the result would be a negative cosine x. The derivative of tangent x is secant squared x, so the integral of secant squared x, or the antiderivative, would be tangent x. Now these are some that are a little odd. If you are super interested in why these things happen, let me know. It's a little more involved to show why this happens than to go into it in a video that I'm trying to keep short, but I will gladly post some informational stuff if you are really interested in knowing why these integrals work this way. But you can kind of see how they would go backwards. The antiderivative would go backwards. For example, e to the x power, the derivative of e to the x power is e to the x power. So it would make sense that the antiderivative doesn't change. A to the x power dx becomes 1 over the natural log of a times a to the x power plus c. And and then the integral of 1 over x dx becomes the natural log of x, or the absolute value of x plus c. So let's go ahead and do a few examples, and then you have some practice problems to do. All right, so I'm going to do these integrals the same way that we did the polynomials. I've got a 2 here, so I'm going to pull the 2 out to the front. So that gives me 2. And then the derivative of cosine x dx is sine x plus c. Now, if you're taking the derivative of multiple things, you can wait and do the plus c at the end, because each one individually will have a plus c. But since you don't know what c is, when all those c's add together, it's just plus c again. So the derivative of cosine x is sine x. And I don't have any other pieces to take the antiderivative or the integral of. So now I can add in my plus c. All right, so let's take a look at this one right here. So this is a good example of that with the plus c's. So another way to write this would be 2 times the integral of sine x plus 3 times dx. I always forget that. 3 times the integral of x squared dx. So the integral of sine x is negative cosine x. And we would have a plus c. So I'm going to write that for now, just so we can see how all of this works. And so this integral would become 3x to the 2 plus 1 power over 2 plus 1. Okay, so plus c. So I'm going to simplify my 2 times negative cosine x, and I can put the negative out in front. So negative 2 cosine x. I'm going to leave my plus c for a minute. This becomes 3 times x to the 3rd power, and then that becomes 3 on the bottom. So the 2 3's are going to cancel out. So this becomes x to the 3rd power, and I've got 2 plus c's. So I'm adding 2 unknown constants. My result is just another unknown constant, so I can just put 1 plus c out here. So you can really wait until the end and put your plus c at the end and make it 1 for the whole problem. All right, so down here we have the integral of secant squared x minus 4 times the integral of x cubed. And I always forget my dx, you guys, always. So the integral of secant squared x, if I look back up at my chart, is tangent x. So tangent x minus 4 times x to the 3 plus 1 over 3 plus 1. Well, conveniently, 3 plus 1 is 4. 3 plus 1 is 4. So this 4 and that 4 cancel out. So the simplified version is tangent x minus x to the 4th power. And now I put in my plus c. All right, so up here I've got 7e to the x power. So that gives me 7 integral e to the x power minus 2, or dx, minus 2 integral sine x dx. So e to the x power, that integral is just the same thing, e to the x power. So 7e to the x power minus 2 times the integral of sine x is negative cosine x. So that gives me 7e to the x power, negative 2, and then the negative cosine. We'll actually make that plus 2 cosine x plus c. All right. So now for this one, I have the integral of a to the x power plus 4 dx plus 4 times the integral of x to the 5th power dx. So my a to the x power becomes 1 over the natural log of a times a to the x power. So 1 over the natural log of a times a to the x power plus 4 times x to the 5 plus 1 over 5 plus 1. So these 5 plus 1s become 6. And then this 4 and this 6 don't cancel out, but they do reduce to 2 and 3. So what I'm left with, I just want it, because this is just a 1, I just want to multiply times a to the x power and put the a to the x power on top. And now here I'm left with 2x to the 6th power over 3 plus c. And then my last problem down here is 1 over 2x. I'm going to break that up first into a coefficient and then my 1 over x dx. So now I can pull my coefficient of 1/2 out to the front. So what that gives me is 1/2, and then the integral of 1 over x dx is the natural log of the absolute value of x. This one's a tough one to write because with all those vertical lines, it all sort of looks the same. So I'm going to make my absolute value lines abnormally tall. So I've got 1/2 times the natural log of the absolute value of x. We could simplify that a little bit more and do the natural log of the absolute value of x over 2. And then we add in our plus c. All right, so make sure that you do your practice problems. There's instructions for turning those in. And I'll be online at 11 if you have any questions.